Namaskar, Adab, Shat Shri Akal. Welcome to the iconic course of CSIR Net. Yes, this evening is dedicated for what? What do you think? What the thing is going to happen? Oh, Mr. Farooq. क्या यार, चलिए तो शुरुआत करते हैं। आज जैसा कि मैंने आपको बताया कि जनरल लीनियर ग्रुप्स के बारे में जो डिस्कशन है वो आज होनी है। जनरल लीनियर ग्रुप्स के साथ साथ जो डिस्कशन हम लोग करने वाले हैं स्पेशल लीनियर ग्रुप का, वो आप देखेंगे कि किस तरीके से स्पेशल लीनियर ग्रुप्स का डिस्कशन होगा। उसके बाद हम लोग क्वाटरनियन ग्रुप और क्लाइन ग्रुप के बारे में जो डिस्कशन है वो निश्चित तौर पे देखने की कोशिश करेंगे। सो सर्टेनली दिस इवनिंग इज गोइंग टू बिकम वेरी इंटरेस्टिंग। गुड इवनिंग अमन जी, यू आर वेलकम। So certainly we are going to discuss everything in detail with concepts, as you can see on our screen over here. Okay, so certainly this we are going to treat, we are going to discuss this GLNF means what? General linear group of order n by n over the field f. And the interesting thing is what? Which kind of f will be there? Is the field f finite? Is the field infinite? What is the meaning of this SL, special linear? What is quaternion groups? Okay, what is Klein 4 groups? So we are going to see the beauty of all these things in a very, very interesting manner. So now let's go to start the session. What do you think? What will be there on the next slide? Nothing. First of all, I would like to say I will define quaternion group, and thereafter I will ask a very simple true false. Okay, and you should answer. Only then you can enjoy this session as similar to offline. Okay, so let's introduce you with the general linear group, है ना। जनरल लीनियर ग्रुप को आज यहाँ पर जो है हम डिस्कस करने की कोशिश करेंगे। यहाँ पर इसका नोटेशन है GLNF. G stands for general, L stands for linear. Okay, this stands for n by n order. So people will ask why this n by n order. Then I would like to say actually this group, I mean to say this is the collection of matrices, and certainly a special kind of matrices, not that special but yes, ठीक है। इस तरह के n by n order के matrices का collection है, जिसमें अगर हम बात करें तो डिटर्मिनेंट ऑफ A जो है वो certainly 0 के बराबर नहीं होगा, मतलब नॉन सिंगुलर matrices का collection है। And why this f is here? What is the reason behind it? Then I would like to say कि जो एलिमेंट्स हम लोग लेंगे a i j वो फील्ड f के अंदर से लेंगे। Yes, we are going to take the elements from this field f, and the interesting thing is what? This f may be a finite field, this f may be an infinite field. So first of all, what do you mean by this notation GLNF? You will say this is nothing but the general linear group of matrices of order n by n whose elements are carried out from this field f. So yes, this collection is called general linear group. Now let me take one case, and you should answer if you are able to give. Okay, so if f is infinite field, if I am taking f as infinite field, some people will ask, what do you mean by infinite field? Then I would like to say the field is like either it is a rational field, real field, or rational field, or complex field. Okay, then what would you like to say about it? What would you like to say about it? I mean to say how shall you define it? कहने का मतलब फील्ड जब या तो रियल है या तो रेशनल है या कॉम्प्लेक्स है, तो फिर कैसे हम चीज़ों को डिफाइन करते हैं। जैसे अगर मैं यहाँ पे GLNR ले लिया, what is the meaning of it? What do you mean by this GLNR? Then in that case I would like to say this is the collection of all square n by n order matrix the collection of all square n by n order matrix such that the determinant of A is not equals to 0 and certainly the elements will be carried out from the set of reals, है ना. एलिमेंट्स जो है वो सेट ऑफ रियल से लिया जाएगा एंड देन वी आर गोइंग टू सी दिस GLNR. अब आप कहोगे कि ठीक है GLNR है तो ऐसे डिफाइन किया गया. In place of R, if you are going to put Q, then you will take the Aij from Q. In place of R, if you will put C, set of complex, then you will just write C over here. I mean to say Aij को आप कहाँ से लोगे? C से. अब देखो जो सवाल है, जो क्वेश्चन है वो क्या है? What is the question over here? First question is what? If n is equals to 1. If n is equals to 1, in this case अगर n बराबर 1 ले लेते हैं इन GLNR में, ठीक है, तो ये क्या हो जाएगा? GL1R. ठीक है, देन आई एम जस्ट गोइंग टू आस्क द ऑर्डर ऑफ दिस, आई मीन टू से GL1R. ठीक है, GL1R का ऑर्डर क्या होगा? व्हाट वुड यू लाइक टू से? व्हाट विल बी द ऑर्डर ऑफ दिस GL1R? व्हाट वुड यू लाइक टू से? I am going to write 4 options and you have to say about it. Option A is infinity, option B is 1, option C is 0 and option D is 5. What would you like to say about it? GL1R, ये जो आपका जनरल लीनियर ग्रुप है 1 by 1 ऑर्डर मैट्रिसेस का, जिसका एंट्रीज रियल्स है, तो इसका ऑर्डर क्या होगा? what will be the order of this GL1R? Please a comment if anybody is there. Certainly I am going to wait for few seconds and thereafter I will give the answer with a proper way of explanation. If anybody is there, then please let me know what do you think. If n is equals to 1, then the order of GL1R is what? What would you like to say? I am just waiting for your response, otherwise I will go for the discussion. If n is equals to 1 in GLNR, then what will be the order of GL1R? I am waiting for your response. If nobody is there to give the answer, then you can easily see, first of all you must think that what is this GL1R? Okay, and this time Aman Shukla is there, and yes Aman, you are absolutely right. Actually what the thing is going to happen, if A is equals to Aij, okay, and it is a matrix of order 1 by 1 with determinant of A is not equals to 0 and Aij belongs to R. Okay, so from here what can you say? You will say this is what? 1 by 1 ऑर्डर के डिटर्मिनांट का क्या मतलब है? 1 by 1 ऑर्डर के डिटर्मिनांट का क्या मतलब है? जैसे 1 है, so this is the matrices of order 1 by 1. अगर 2 है तो 2 मैट्रिक्स ऑफ ऑर्डर 1 by 1. तो यहाँ पे ये सारी चीज़ें हैं, ठीक है. फिर यहाँ पे 3 है तो मैट्रिक्स ऑफ ऑर्डर 1 by 1, ये सारी चीज़ें हैं. ऑल राइट, तो अब यहाँ पे क्या है कि ऐसा चाहिए नंबर जो 0 के बराबर नहीं है. तो GL1R is nothing but the collection of all real numbers except 0. So you will write it as R without 0. And R without 0 is going to be denoted as R star, and this R star is what? The collection of all non-zero reals. And what do you think about its cardinality? Certainly its cardinality is Aleph 1, uncountable, है ना, रियल एनालिसिस से देखे. लेकिन फिलहाल ग्रुप थ्योरी में इसको हम सीधे इन्फिनिटी लिख के छोड़ देंगे, है ना. अगर यहाँ पे इन्फिनिटी लिख रहे हैं बट एक्चुअल रियल एनालिसिस के चश्मे से देखें तो आर स्टार का जो कार्नलिटी है दैट विल बी व्हाट? अलेफ 1. आई मीन टू से अलेफ 1 इज द कार्नलिटी ऑफ एनी अनकाउंटेबल सेट, isn't it? So Aleph 1, but to make the things simple I am just going to write infinity. तो यहाँ पे GL1R का जो ऑर्डर है वो आपका यहाँ पे क्या आ गया? तो निश्चित तौर पे इन्फिनिटी आ गया है. अब मैं यहाँ पे जो है, लेट मी टेक अनदर क्वेश्चन और केस, यू कैन से इफ वी आर गोइंग टू टेक n ग्रेटर देन और इक्वल टू 2, देन इन दैट केस GLNR is equals to what? A is equals to Aij n cross n such that determinant of A is not equals to 0 and Aij belongs to R. Okay, then what do you think? What will be the thing? Then in that case you can say what? You can say what? The order of GLNR will be what? What do you think? The order of वैभव वर्मा जी, यू आर सेइंग कब सही होगा एग्जाम IIT जेम देना सेमेस्टर 4 के स्टूडेंट को? अपकमिंग जो है वो दे दीजिए वैभव जी. मिस्टर वैभव, आई वुड लाइक टू से यू मस्ट गिव द अपकमिंग एग्जाम फॉर श्योर फॉर द सेमेस्टर 4 स्टूडेंट. आप सेमेस्टर 4 में हो तो आई थिंक इसके बाद 2 सेमेस्टर्स और होंगे, है ना? तो आप अपियरिंग में दे सकते हो, है ना? सेमेस्टर 6 में जनरली लोग देते ही देते हैं ठीक है, एडमिशन लेने के लिए. तो आपके पास 1 साल है, अच्छी तैयारी कर लीजिए एंड देयर आफ्टर यू शुड गिव द एग्जाम अपियरिंग में सेमेस्टर 6 में. लेकिन तैयारी अभी से शुरू कर देनी चाहिए, दैट विल बी द बेटर थिंग. ओके, सो व्हाट विल बी द ऑर्डर फॉर GLNR? सो GLNR इट विल बी इन्फिनिटी, है ना? मेरे दिमाग में ये चल रहा था 3 साल होता है ना, तो 6 सेमेस्टर में तो सर्टेनली यू हैव टू गिव द एग्जाम एंड यू शुड प्रिपेयर सो दैट यू कैन क्लियर इट by just completing your graduation, and for masters you can go for any IIT. Vaibhav ji, and my best wishes is with you also. So if you will take n greater than or equal to 2, तो 2 by 2 order के कितने matrices होंगे? ठीक है, 2 by 2 order के कितने matrices होंगे? ठीक है, अब यहाँ पे हम एलिमेंट्स कहाँ से ले रहे हैं? सेट ऑफ रियल से. So if we are going to take the elements from set of reals, and the cardinality of set of reals is what? Uncountable. So certainly it will be infinite in number. So है ना, GL1R and GLNR, अगर मैं आपसे पूछूं GL2R, GL3R, GL4R का कार्नलिटी क्या होगा? What will be the carnality of all those? Then certainly you will say what? Infinite. Okay, so Vaibhav ji, I would like to say you should take the classes, and I will be very regular on this channel, and real analysis has already completed, and that will be more than enough for IIT JAM, because that course has been completed by taking the syllabus of CSIR NET in mind, and IIT JAM also. तो रियल एनालिसिस ऑलरेडी कंप्लीट कर दिया है, जो कि सबसे ज़्यादा पूछा जाता है. देयर आफ्टर आई एम गोइंग टू कंप्लीट दिस ग्रुप थ्योरी एज वेल, एंड आई विल नॉट कंप्लीट ओनली ग्रुप थ्योरी, बट जस्ट विल कंटिन्यू इट फॉर द रिंग थ्योरी एंड फील्ड थ्योरी फॉर ऑल्सो. सो यू शुड जनरली आई यूज टू कम एट 8 PM डेली, एंड यू कैन ज्वाइन अस. नाउ इफ आई एम गोइंग टू आस्क अनदर केस, देन व्हाट वुड यू लाइक टू से? If f is a finite field, if f is a finite field, so what do you mean by this f is a finite field? For example, if I will ask you the order of GL2 F2, then what would you like to say? What will be its answer? Some people will say that without giving the formula, how can you ask this question from me? I would like to say I am not going to ask you, but first of all I just want to see some of you who has already done this topic, can they revise, can they answer, and thereafter I will give you the general formula for finite field, so that you can give the answer of this kind of question very quickly, easily, है ना? तो इस क्वेश्चन का जवाब दीजिए. उसके बाद इसका जो जनरल फॉर्मूला होता है GLNFQ का, जो जनरल फॉर्मूला होता है, वो हम यहाँ पे समझेंगे, जानेंगे, जानने की कोशिश करेंगे कि कैसे GL2 F2 जैसे ग्रुप्स का ऑर्डर फाइंड आउट किया जाता है. ओके, सो सर्टेनली वी आर गोइंग टू लर्न all these things. Okay, so please try your level best, and thereafter I will give you the general formula for this kind of question. And this time Aman Shukla ji once again absolutely right, and because there is a formula, I would like to say, if f is a finite field, if you can write with me, if f is a finite field, if f is a finite field, say f is equals to fq is equals to zq is equals to 0, 1, 2 up till q minus 1. Okay, then what do you think? Then zln fq is equals to what? Certainly this is a, which is aij, such that determinant of a is not equals to 0 and aij belongs to fq. This is how this zln fq is defined, है ना? This is how this gln fq is defined. What? The matrices, determinant of that matrix is not 0, it means it should be what? Non-singular, and the elements aij has taken from this field fq. In that case, there is a formula for the order of z, and by using permutation and combination we used to count it, and that counting says the order of this zln fq, let me write it properly, the order of zln fq is given by q raised to the power n minus q raised to the power n minus 1 into q raised to the power n minus q raised to the power n minus 2, and by doing so q raised to the power n minus 1. Okay, so yes, so this is the formula, and by using this formula you will not hesitate to say the right thing. Yes, so what do you think? What would you like to say? So here in place of n we have 2, in place of q we have 2. So what is the formula right here? Q raised to the power n minus q raised to the power n minus 1 into q raised to the power n minus q raised to the power n minus 2. So by doing this, what can we say? 2 raised to the power 2 and minus 2 raised to the power 2 minus 1 into 2 raised to the power 2 minus 1. Why? Because 2 raised to the power 0 is 1. So here you will not hesitate to say 4 minus 2. So certainly this is 2. And into 4 minus 1 is what? 3. So 3 2 ja 6. So the order of ZL2 F2 will be what? 6 for sure. So yes. So this is how we can remember if we have a general linear group like this ZLN FQ. FQ denote a finite field. Then what would we like to say about? Certainly we would like to say that the order of ZLN FQ is nothing but q raised to the power n minus q raised to the power n minus 1, q raised to the power n minus q raised to the power n minus 2, and by doing this manner we will reach over here q raised to the power n minus 1. So this is the order of this general linear group, which is the collection of n by n order matrices with the entries from this field FQ, which is certainly a finite field. Now I am interested with a spatial linear group. Yes, now I am going to discuss about a spatial linear group, and you have to be a bit careful to say something whenever the things are going to be asked, then you should be a little bit careful to say anything. So a spatial linear group. Okay, so before this we have discussed about general linear group, and now we are going to put some extra condition and it will make it special. Okay, so first of all, how this is going to be denoted? So you can denote it as this SLNF. Okay, so SLNF means what? This n denotes the order n by n, and this f means what? We have to take the elements from this f. How this is going to be defined? You will not hesitate to say our A is what? Aij n by n, and determinant of A is equals to 1, and Aij belongs to F. Aij belongs to F. So in this case, what can we say? If F is equals to R, C or Q. I mean to say, if your field is either real or complex or rationals, then how shall you define your SL and R? Certainly you will not hesitate to say SL and R is what? The collection of all the matrices of order n by n. Okay. But this kind of group is special. So certainly this its determinant will be 1. Remember, for the general linear group, the determinant was what? Non-zero. But now we are going to put a special condition. We are going to take the determinants of matrices is equals to 1. So that's make this group special, because we have to collect all the matrices whose determinant is going to become 1. And Aij belongs to where? R. Why this Aij belongs to R? Because we have put R over here. If we will put C in place of R, then certainly our entries will belong to this C. If we will put Q in place of R, then the entries will belong to Q. But for a special linear group, we will not forget that its condition is its determinant must be equals to 1. Okay, so this is what the special linear group whose entries are from R and order is n by n. So now, are you ready to give the answer of very first question? Yes or no? Yes, you have to be a bit careful to say. If n is equals to 1, then what would you like to say about the order of SL1R? What would you like to say? What will be the order of this group? If n is equals to 1, then what will be the order of SL1R? Option A is 1, option B is infinity, option C is 5, option D is none. You are welcome to speak. If you have a clear-cut visualization about SL1R, then there should not be any hesitation to say anything. You are welcome to speak undoubtedly. What will be the order of SL1R? If anybody is there who is preparing for CSIR net, then certainly they are welcome to speak. And I can see one response is over here, Aman Shuklaji, and he is absolutely right, because a clear-cut picture is there in his mind that if the thing is written as SL1R, it means this is the collection of all 1 by 1 order matrix, undoubtedly 1 by 1 order matrix whose determinant is equals to 1 and the entries belongs to R. And the entries belongs to R. And in the world of real number, if you are going to take a 1 by 1, it means what? You are just going to pick out, you are just going to pick a real number only, है ना? आप सिर्फ क्या कर रहे हो? एक रियल नंबर को पिक करना चाहते हो जिसका डिटर्मिनांट 1 हो. तो क्या वह 1 के अलावा कोई और होगा? नहीं. इसका मतलब SL1R में कितने एलिमेंट है? 1. और वो किस रूप में है? तो सिर्फ 1 के रूप में. तो इसीलिए देखिए, इट इज वेरी इंटरेस्टिंग टू नोट that the order of GL1R was infinity, but the order of SL1R is 1. And I hope you understand why this is. Okay. Now, once again, I would like to ask a very simple question, that if n is greater than or equal to 2, if n is greater than or equal to 2, then what would you like to say about the order of SL and R? What would you like to say about the order of SL and R? Remember, your n is greater than or equal to 2. Would you like to say it infinity? Would you like to say it infinity? Yes or no? Because your n is greater than or equal to 2, it means you are going to collect all the n by n order matrices whose determinant is equals to 1. Okay, and entries belongs to R. Okay, so you have to find the cardinality of this set. Then what would you like to say? How many elements will be there? infinitely many, because you can, because n by n ऑर्डर का है तो 2 by 2 ऑर्डर के बहुत सारे ऐसे मैट्रिक्स मिलेंगे जिसका डिटर्मिनेंट 1 हो, 3 by 3 ऑर्डर के इनफाइनाइटली मेनी मैट्रिक्स जिसके डिटर्मिनेंट 1, तो इसका कार्नलिटी हो जाएगा इन्फिनिटी. बट व्हाट डू यू थिंक इफ योर फील्ड विल बी अ फाइनाइट फील्ड, इफ योर फील्ड f is equals to the field like this fq or zq sometimes we used to write, and certainly as a finite field you can write the collection like this, then what would you like to say about the order of sln fq? What would you like to say? What will be the things for glnq? You cannot forget the formula qn minus 1 and qn minus 2, and by doing this process qn minus 1 were the thing, and divided by what? Q minus 1. So remember, for a special linear group we are going to divide by q minus 1 total number of. So what do you think if I will ask you about the order of SL2 F2? If I will ask you about the order of SL2 F2, then what would you like to say? Order of SL2 F2 will be what? क्या होगा? Order of GL2 F2 क्या हुआ था? 6 हुआ था. क्या ये भी 6 हो जाएगा? Because the things in the numerator is same as GL and FQ, है ना? जो न्यूमरेटर में GLNFQ के लिए था वही चीज यहां पे भी है, बट स्पेशल होने के कारण Q माइनस 1 से डिवाइड हो गया, इजंट इट? Q माइनस 1 से क्या हो गया? डिवाइड हो गया. तो फिर से आप फॉर्मूला लगाओगे, यू विल गेट 2 to the power 2 minus 2 to the power 2 minus 1, है ना? बिकॉज हेयर योर Q इज ऑल्सो 2 and your n is also 2. So that's why q to the power n minus q to the power n minus 1 into q to the power n minus q to the power n minus 2 and divided by what? 2 minus 1. So it will become what? 4 minus 2, isn't it fine? Yes, and into 4 minus 1 and divided by 1. So what would you like to say? It is 2 into 3 is equals to 6. Okay. So for SL2 F2 the order is 6, for GL2 F2 the order is 6. Yes, Aman Shukla ji and Rajiv Gandhi ji. Okay, so I would like to say that I will try to explain everything in both the medium, Rajiv ji, English and Hindi, है ना? दोनों ही अब लैंग्वेज में मैं इसको जो भी हमारा कॉन्सेप्ट है उसको क्लियर करने की कोशिश करूंगा. यस, now I am going to introduce you with Quaternion group. Yes, you can see a beautiful picture over here, and this represents the Cayley table of Quaternion group. Yes, this beautiful picture represents the Cayley table of Quaternion group. Okay, so first of all I would like to write the Quaternion group in style so that you can understand what the thing is there. So Q4 is what? Actually plus minus 1 plus minus I plus minus j and plus minus k. Okay, so this is the thing over here, these are the elements. But people will ask that what algebra is going to be followed? Then in that case I would like to say I square is equals to j square is equals to k square is equals to minus 1. Thereafter ij is equals to minus ji is equals to k. This is how the algebra is going to be, and I will show you how it is there inside this Cayley table, है ना? And here ki is equals to minus ik is equals to j. So first of all you can ask how this is minus k, then I would like to say see minus I dot j is equals to minus k. So minus I dot j is equals to, so first of all you can see I dot j is equals to k, and if minus sign is already over here then we can just put a minus before this k and we cannot stop to say yes, it's fine. Another thing is what? if it is minus 1, then you can see the algebra j into j, certainly minus minus plus j square, and j square is minus 1. That's why this is written over here. I will tell you to find the inverse of each and every element, and by just seeing this scalar table you will be able to say this, say everything without any hesitation. So first of all, I think you are able to write this scalar table undoubtedly by using this algebra, isn't it? Yes or no? Because if it is written I over here and I over here, then I square, and I square is already given as minus 1. So we will not hesitate to say that this I dot I is equals to minus 1. So I hope you understand how this scalar table is there. मैं उम्मीद करता हूं कि आप यह जानते हैं कि स्केलर टेबल कैसे बना. ठीक है. Now I am just going to ask about the identity element, then you will not hesitate to say that the identity element is nothing but this one. Okay, you will not hesitate to say 1 is the identity element for this. Okay, now I would like to ask what will be the inverse element. So what would you like to say about the inverse of this? How you used to understand? कैसे आप समझते हैं कि inverse क्या है? तो ये आपका 1 है, so you can just see in the right, in the leftmost column and uppermost column 1 is there. So inverse of 1 is 1. Now I want to see the inverse of minus 1, then I will just look at over here. Oh, this is the identity. It means this leftmost element and this uppermost elements are what? The inverse of each other. So the inverse of minus 1 is certainly minus 1. Okay. Thereafter we can see what? Here is 1 and 1, you can see how this one has come up, I and minus I. Okay, so the inverse of I is what? Minus I. So this is how we used to find the inverse of element. If here is 1, then the inverse of minus I is I. If here is 1, it means the inverse of j is what? Minus j. If here is 1, it means the inverse of minus j is what? Plus j. If here is 1, it means the inverse of plus k is what? Minus k. If here is 1, then the inverse of minus k is what? Certainly plus k. Isn't it? So this is how you are going to find the inverse element. है ना? इस तरीके से हर एक का inverse आप find out कर सकते हो. ठीक है. Will it be abelian? What do you think? Do you dare to say it will be abelian? Yes or no? Is anybody there who can say that it is abelian? What is the characteristic? By just seeing this scalar table, how will you say it is abelian or not? First of all, you have to make a diagonal over here. You have to make a diagonal over here, right? And after making a diagonal, if this table is symmetric about this main diagonal, in that case you will be able to say. But if you will take this main diagonal as the mirror, then you are able to see, oh, here was minus k, but its image is not there. I mean to say कि इस लाइन के अबाउट ये सिमेट्रिक नहीं है और अबेलियन नहीं है, वो तो यहाँ से भी दिख रहा है कि आई जे माइनस जे के बराबर है. ठीक है, आई जे इज इक्वल टू जे आई है नहीं, यहाँ पे आई जे जो है वो जे आई के बराबर नहीं है. सो दैट्स वाई इट्स नॉन अबेलियन. इट्स क्लियर. सो दिस इज व्हाट? क्वाटरनियन ग्रुप. ठीक है. सो आई होप दिस इज क्लियर. आई होप दिस इज फाइन. एंड नाउ आई वुड लाइक टू से certainly I will introduce some beautiful groups like Klein 4 group and many things related to it. Okay, Klein 4 group is also very interesting. So certainly we will discuss, but not today. We'll discuss it tomorrow. I would like to say due to rain, I was not able to come on time, but usually my class is going to happen at 8 p.m. daily. Okay. I have a Telegram group, WhatsApp group. Okay, so if you will type this thing on the Telegram, then certainly you can join to get updates and everything, and you can join the WhatsApp group on this number as well. If you want, then certainly you are welcome. 8076603648. This is the WhatsApp group number. If you will ping me, then certainly I will add you. Otherwise, you can join yourself on this Telegram channel as well, whose name is similar to our YouTube channel, PK Maths Pankaj 13. Type in the same manner PK Maths in capital, thereafter in small, and certainly you will be able to join us. If you will send your question, and if it is according to our grading of this course, then I will take those questions in the live class for sure. Okay, or you can WhatsApp your doubts on this number, but you have to keep patience. Whenever I will get time, then either I will reply or consider that question in the live class for sure. So we'll see you tomorrow at 8 p.m. Don't forget to join. Don't forget to continue. Don't think that you are on YouTube. Okay, you just need to think that you are in the classroom and you have to study in your own way. So certainly we are going to meet tomorrow at 8 p.m. Till then, take care. Bye bye. I wish you all the best. See you tomorrow. Thank you very much, all of you. Jai Hind, Jai Bharat, Vande Mataram. Thank you, Rajiv ji. Please share these sessions to the needy who is preparing for CSIR NET or IIT exam, because it gives me the motivation to continue the course with energy. Okay, so I hope you people will do it, and certainly we will meet tomorrow as well. Okay, so thank you very much. We'll see you tomorrow. Till then, take care. Bye bye.